Welcome to the Unit 3, Section 4 video on evaluating functions. Recall, the purpose of a function is to take some input and generate an output. You have some input x, it goes into a function, and the result is your y value or your output. You can think of a function as an input-output machine, where your function, f of x, is that machine that your input goes into and your output, y, comes out of. The input of a function is the independent variable. The output of a function is the dependent variable. The value of the dependent variable depends on or is a function of the value of the independent variable. There are several different ways to describe the variables of a function. An independent variable is your x value. Your dependent variable is your y value. Your independent variable is your domain. The dependent variables are your range. Your independent variable is your input. Your dependent variable is your output. Your independent variable is your x. Your dependent variable is your f of x. So now let's talk about evaluating functions. Since every input has a corresponding output, a function represented by a set of ordered pairs or table can be evaluated by simply identifying the y value that corresponds to the x value. So in a table, it's fairly simple. If we want to find f of x when x equals 1, we'd find 1 on our table as our x value and find the y value that goes with it, and that would be 8. For x equals 5, the y value that goes with it is 98, so f of 5 is 98. When we're dealing with a set of ordered pairs, same sort of concept here. When x equals -2, our y value that goes with it is 1, so f of -2 is 1. F of 4, we go to where x is 4 in our ordered pairs, and the y that goes with it is 7. Now, when a function is given as a graph, the principle remains the same. Use the input value to find the corresponding output. To do this, find the x value on the x-axis. Then follow the x value up or down until you reach the graph of the function. Finally, follow the y value horizontally to the y-axis to read the value for the output. So in this graph, to find f of 6, we are going to find x equals 6, and then we follow that up to the graph of the function. Then we're going to follow the horizontal line back to the y-axis and find that y is equal to 4. So f of 6 equals 4. So let's do an example of this. Here we're going to find f of -4. So we find -4 on the x-axis. We follow that down to the line of our graph. Then we follow the horizontal line at that point back to our y-axis, and we find that f of -4 is -3. For x equals 2, we are going to follow 2 to our graph. Well, there's nowhere to go. We're already at our graph. So therefore, this value, this y value, is going to be 0. So f of 2 is 0. An algebraic expression that defines a function is a function rule. If x is the independent variable and y is the dependent variable, then function notation for y is f of x, read f of x. Okay, we've already been using that terminology, where f names the function. In function notation, the function f of x is being evaluated at some input x. So an equation may be y equals 3x minus 8, read as y equals 3x minus 8. The x represents the input, the y represents the output. The only difference in function notation is that we have f of x equals 3x minus 8, where x again is the input, and f of x represents the output. To evaluate a function, find the value of f of x by substituting a number for x and simplify using the order of operations. So in example 4, for f of x equals 5x, we're going to find f of x when x equals 6 and when x equals 7.5. So for x equals 6, we're going to find f of 6, which means we substitute 6 in for x. 5 times 6 gives us 30, so f of 6 is equal to 30. We can do the same thing for 7.5. Plug that in for x and multiply, and we get f of 7.5 equals 37.5. For g of t equals 2.30t plus 10, we're going to find when t equals 2 and when t equals negative 5. So first, take our function, plug 2 in for t, and then evaluate. We multiply first, and then we add to get g of 2 equals 14.6. For t equals negative 5, same process. Start with our function, plug in negative 5 for our t, multiply first, and then add to get negative 1.5. For example 6, again, the process remains the same. Start with our function. We're going to start with finding when x equals 12 what our output is. So we're going to put 12 in for x, multiply, and then subtract to get h of 12 equals 3. When we want to do the same problem when x is negative 8, we plug in negative 8 for x, multiply, and then subtract to find that h of negative 8 equals negative 7. For this example, we have 2c minus 1. We want to find when c equals 1, so we substitute in 1 for c. And we get 2 times 1 is 2. 2 minus 1 gives us 1, so h of 1 is 1. When c equals negative 3, we're going to plug in negative 3 for c. 2 times negative 3 gives us negative 6. Negative 6 minus 1 gives us negative 7. For this example, we want to find when t equals negative 24, so we're going to plug in negative 24 for t. 1/4 times negative 24, or you can also say negative 24 divided by 4. It's going to give us negative 6. Negative 6 plus 1 gives us negative 5. So g of negative 24 is equal to negative 5. When t equals 400, plug in 400 for t. 400 divided by 4 is 100, and 100 plus 1 gives us 101. So h of 400 is 101. Thanks for checking out my video in the Foundations in Algebra series. You can subscribe to my channel. I've got the next video queued up for you, and if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.